Here go recommended questions 15, 17, and 19 from section 4.1. So if you watched the previous video, that should give you a good idea of how we should do basic derivatives. So I'm not going to redo that. So in this case, in 15, we want to find the derivative. So we want to find the derivative of the function p of x. So we're going to use the power rule here. We're going to get negative 1/2 times negative 10x, negative 1/2 minus 2. Let me get, whoops. So negative 1/2 minus 2, what am I talking about? Negative 1/2 minus 1 is negative 3/2. We're also going to bring this negative 3/2 down. Negative 3/2 times 8x. Negative 3/2 minus 1 is going to be negative 5/2. We can clean this up a little bit. So negative 1/2 times negative 10 is 5x to the negative 3/2. We can also see that it's 5/x to the 3/2. Plus negative 3/2 times 8 is going to be negative 12. So we can change it to a minus 12x to the negative 5/2, which will be the same thing as negative 12 over x to the 5/2. Question 17. We have to rewrite 17, or we probably should rewrite 17. So we can say that this is y equals 6 to the x raised to the 1/4 power. We have a couple of different ways of doing this question. So let's do them a few different ways just in case. The derivative is going to be, well, we may want to rewrite this as 6x to the negative 1/4. And in that case, we're going to get negative 1/4 times 6. X to the negative 1/4 minus 1 is negative 5/4. So that's going to be negative 1/4 of 6 is going to be negative 3/2. X to the negative 5/4. And again, we may see this as negative 3/2 x to the 5/4. That's one way. We also had a power rule for taking the derivative of 1 over x to the n. It was negative n over x to the n plus 1. So in this situation, if we look at this, n is 1/4. So the derivative of, whoops, that was just bad. Derivative of 6 over x to the 1/4. We can bring this 1/4 up to the numerator as a negative, and we can just add 1 to the 1/4 in the denominator to get 5/4. So we'd get a negative 3/2 over x to the 5/4, and that's the exact same thing as this when we write it as negative 3/2 x to the 5/4. For question 19, this is a question where in 4.2 we'll see a different way of doing this using what's called the quotient rule. But even if we could use a quotient rule here, we want to actually write this in a smarter way. So we can rewrite this function as x cubed divided by x plus 5 over x, which we can simplify into y equals x squared plus 5 over x. Alright, so then now, since we've rewritten this in a way that we can now take the derivative of, let's just take the derivative in pieces. So the derivative is going to be equal to, the derivative of x squared is 2x, 5x. We can either write this 5x as 5x to the negative 1 and use the power rule, or we can use this rule right here again. We can bring this 1 up as a negative to the numerator, and then just add 1 to that exponent, which is going to give us 2x minus 5 over x squared. That's what our derivative is going to equal.